Hello guys, welcome to my YouTube channel. Today we are going to look at PN junction. What is a PN junction? A PN junction, when an N-type semiconductor and a P-type semiconductor is suitably joined, the contact surface is known as a PN junction. From our previous class, we looked at the formation of N-type and the P-type semiconductors. We said that N-type semiconductors, the electrons are the majority charge carriers. Electrons are the majority charge carriers. But in this N-type semiconductor, we also have holes, but holes are the minority charge carriers. We have some holes here which are the minority charge carriers. And also we say that a P-type semiconductor, we say that holes are the majority charge carriers. We say that holes are the majority charge carriers and holes are positively charged. But also here we have electrons as the minority charge carriers. If we join these two semiconductors, the contact surface is known as a PN junction. If we join this surface, the contact surface is the PN junction. Most semiconductor devices contain one or more PN junctions, as the PN junction is of great importance if we understand what is a PN junction. Let us see the formation of a PN junction. As we're going to form a PN junction using the N-type semiconductors and the P-type semiconductors. When the fact of forming a PN junction is that when we bring these two semiconductors, the contact surface is called the PN junction. If we now bring that this is our N-type semiconductor, P-type, the contact surface here is the PN junction. We have said that here have electrons as the minority charge carriers, but also here electrons are the minority charge carriers. Let me represent here as P, let me represent here as N. Here electrons are the minority charge carriers, here holes are the majority charge carriers. But in the process of forming this PN junction, we've said that the fact is that we bring an indium and an N-type germanium crystal. We bring up the indium and the germanium crystal. We consider this case. We will say that when indium and N-type germanium crystal is heated, when these two are heated to a temperature of about 500 degrees Celsius, this indium and the N-type germanium crystal, they will melt. Indium and germanium crystal melts. These two melts. When we reduce the temperature, or lower the temperature, the indium mixture under proper conditions solidifies. The indium germanium crystal solidifies under proper conditions. Then we will realize that addition of the indium crystal overcomes the excess of electrons, in the surface of the germanium crystal to form a P-type region, meaning that region now NP. We will say that the surface, a p-type region will be formed, meaning that here we will have a boundary here. We have a boundary here. This region, there is no electrons in this region because the electrons in the n-type diffused to the p-type, and also the holes in the p-type diffused to the n-type, meaning that this region here, let me draw it in a bigger way. This region now here, this is the N and this is the P. The region near the N-type semiconductor holes are the ions present here. And this region near the P-type, electrons are the ions there. Then here is depleted of the charges. This region is depleted of the charges. Here we have electrons. Here we have the holes. Meaning that this region here, this region is depleted of the charge carriers. Therefore, we will say that this is the formation of a p-n junction. We will look at the characteristics or the properties of the p-n junction. p-n junction. Property number one we have looked at of the p-n junction. We have said that the p-n junction is depleted. p-n junction is depleted of the majority charge carriers. Is depleted of the majority charge carriers because this region has no charges. Property number two, we will say that a p-n junction has a potential difference. A p-n junction has a potential difference because here the point, this junction and here are the positive ions and here are the negative ions. We will say that the p-n junction has the potential difference. We also say that the p-n junction does not conduct. The p-n junction does not conduct. This region does not conduct current because it is depleted of the charge carriers, and that is all about the p-n junction. In our next lecture, we are going to look at how voltage is applied on the p-n junction. We apply voltage in a p-n junction either by the forward biasing or the reverse biasing of the p-n junction. Thank you so much. We meet in our next lecture.